All right, so this is the green homework, inverse trig values 2. This is number 19, and I will talk about any others that you need. But 19 is arctangent of the tangent of negative 4 pi sevenths, just like that. Okay. So, if you weren't sure what to do, you need to know that maybe you can't just cancel them out. Yes, these are inverses of each other, right? However, they don't always just cancel each other out. So you have to think about this. Negative 4 pi sevenths. Which quadrant would that angle be in? No. Because this is negative 3 pi halves. This is more than that. It'd actually be over here like in the third quadrant. Does that make sense to you? Okay, so do you know what the tangent of negative 4 pi sevenths is? No, you don't, right? And that's okay. But you don't need to. Here's what you need to know. Is that if I did know what the tangent of negative 4 pi sevenths is this answer positive or negative? I'm in the third quadrant, so it's positive, right? So I would get a positive value. Does that make sense to you? So if sometimes these do just cancel, and that would be my answer. It's going to be something that's related to that answer. So if I take the arctangent of a positive number, which quadrant am I in? Tangent inverse of a positive number gives me an answer in what quadrant? The first one. Because remember, when you do inverses, bless you, for a tangent, you are restricted to the first and the fourth quadrant. Yes? So I know that whatever I'm taking the arctangent of, it's some positive number. My answer is going to be a first quadrant angle. So what I want is the first quadrant, oops, what the heck? The first quadrant, oh my goodness, now I've really screwed this up. Okay. I want the first quadrant version of that. It's still too thick. So the first quadrant version of that would be my reference angle. Yes? So if I'm here if this right here is negative 4 pi sevenths, my reference angle is right here. What would it be? From here, 3/7, because from here all the way to here is 7/7, right? This is negative 4 pi sevenths, so I'd have to go another negative 3 pi sevenths, but my reference angle is always positive. So this would be 3 pi sevenths, and that would be my answer because that's my positive reference angle. Okay? That's the same thought process as, what's another one as number 15. It's actually the same thought process, really, as a 15 and 18. How many of you missed 15? Okay, same thought process here. So here's 15. 15, and if it's been a while since you thought about it, let's think about it again. I want the sine of the cosine. Oh, this is one where it should be, this should be of the cosine inverse of negative 4/5. Okay. So if I take the cosine inverse of a negative number, what quadrant will I be in? It's not the same thought process, a little bit different. But cosine inverse of a negative number, what quadrant am I in? The second, okay? So now I'm in the second quadrant, and this one we did have to draw a little, this was not the one I was trying to get, but it's okay. Negative 4/5, right? And so this is a 3. So my sign, you can just get straight from that 3/5. But I know that it's going to be positive. You have to think about what quadrant you're in there. That's not the one I was trying to explain. But that's where you would get your 3/5 from if you did miss that one. I was looking for one where you took the inverse and they didn't just cancel out. 18? Okay, so it's 18. All right, so 18 was a problem too. So let's look at 18. That's what I was trying to do there. So 18 is the cosine inverse of the cosine of negative pi fifths, just like this. Okay, so here's one where they don't just cancel each other out, right? Instead, when I take the cosine of a negative angle, this right here is in which quadrant? What's the cosine of negative pi fifths? What's the cosine of, or what quadrant would I be in? Fourth quadrant, right? So if I take the cosine inverse of this right here, is cosine positive or negative here? All students take calculus, positive, positive, right? So if I take the cosine of this, I'm going to get a number down here that is positive, right? And when you take the cosine inverse of a positive number, what quadrant are you in? First, because you were restricted to the first and the second quadrant. So although this is negative pi fifths right here, my answers can only be first and second quadrant angles. So this right here has to be a positive pi fifths. Think about your signs, not necessarily the values. You don't know what that value is, and that's okay. And just remember, your cosine inverse answers are always positive. Cosine inverse, always positive. That's because we are looking at first and second quadrant angles, right? Sine inverse and cosine inverse are plus or minus the reference angle. Okay, because we are in the first and fourth, but we don't name them as fourth quadrant angles. Ah, dang it. Yes, tangent, thank you. Tangent inverse. So sine inverse and tangent inverse are always plus or minus the reference angle, whatever it happens to be. And so technically, this is always the reference angle and pi minus the reference angle. That's how you get them both to be positive, if you understand how to find your reference angles there. Does that help there? No? Any other questions on that homework? Any other questions on any of the homework, or have you even had time to look at that? Yes, ma'am. Remember which one? I'm sorry. 14? Okay. All right, so let's look at 14 there. And if you don't need help with 14, maybe look through the rest of your homework and see if you have any other ones that you have questions on. 14. I want the sine of the tangent inverse of 3/2. Okay. So what I have to do here, since these don't match, is I have to draw my little triangles, right? So, and I had this question earlier, so in case you were confused yourself here, the tangent inverse, when tangent is positive in which quadrants? First and third. But when I'm taking the inverse, I am restricted to only the first and fourth, right? So when I do that, I know that this is a first quadrant angle. And I'm going to draw my triangle here. Tangent is opposite over adjacent, so this is 3 and this is 2. Okay? Opposite over adjacent, or it's your y over x, sine over cosine, right? So then I have to figure out what the hypotenuse is. So it's just Pythagorean theorem. So it's just 3 squared plus 2 squared equals r squared. So that's 9 plus 4, so this is the square root of 13. So now I know I'm in the first quadrant, and when I want the sine here, the sine is just y over r, or it's opposite over hypotenuse. So that means it's going to give me 3 over the square root of 13. But then I have to rationalize. So that has to be square root of 13 over the square root of 13. 3 square root of 13. 13. Does that help? Yeah? Mm-hmm. Okay, so what you have to ask yourself is, you are taking the inverse, and this is what you're thinking of, that little half circle. Where is it positive? If that was a negative 3/2, then it has to be in the fourth quadrant. Okay, does that make sense to you? Everybody good? All right, anything else on any of the homeworks that you had questions on, or that quiz, or anything? We all good? Okay, so you just want to work on your review and let me know if you have questions, or if you have questions on any other homeworks, let me know. Alrighty, let me find my paper for that. Number 14. Alrighty. So this is the blue, right? Mine's not blue. Blue double angle identities, number 14, if you need this one. So tangents of 2 theta. All right. And let's see. It gave me that sine theta is 1/3, and it says it's in quadrant 1. So here's my triangle. Sine is opposite over hypotenuse. So then I do Pythagorean theorem, and that's going to be 9 minus 1, which is the square root of 8. Oh, some of y'all missed one of these or some of these because you didn't simplify your square roots. Make sure you're doing that. This becomes 2 square root of 2. Your answers have to be rationalized and simplified and all that good kind of stuff. So on any of these, and of course this doesn't ask for all of them, but I would go ahead and figure out my other things here. So my cosine theta would be adjacent over hypotenuse, 2 square root of 2 over 3. And then my tangent theta would be 1 over 2 square root of 2. Okay, because it's opposite over adjacent. But the problem is I have a square root in the denominator, right? So I'm going to rationalize. So this gives me the square root of 2 over 4. Okay, so that's just to get me started because I need that information to be able to do this, right? Then I need to know what I change this to. This becomes tangent theta over 1 minus tangent squared theta. Right? You with me? All right. So now I just substitute, since I already did all that, I'm just substituting it in. So I'm going to do 2 times the square root of 2 over 4 over 1 minus the square root of 2 over 4 squared. Okay, so here's some of the things that I've seen from some of you that I know you know what you're doing, but these are the kind of weird little mistakes you're making, is not actually squaring when you're supposed to square, or not change, if that was negative, not making it positive when you square. And I know you know better, it's just like stupid little things that are happening. And somehow losing one of the denominators when it's a fraction and a fraction, so just be careful with what you're doing here. All right, so as I do this, if I think about this as being over 1, this is 2 square root of 2 over 4, which really just becomes square root of 2 over 2, right? And then this is going to be 1 minus, well, when I square this, the square root of 2 squared is 2 over 16, right, because it's square root of 4. So then I'm going to keep going, and I'm going to make this square root of 2 over 2. I'm just going to leave that there for right now. Oh, and then down here, this really is just 1/8, right? So 1 minus 1/8 would be like 8 over 8 minus 1/8, so that's just 7/8, right? So now, dividing fractions, that's going to be square root of 2 over 2 times 8 over 7. And then I can reduce that, so I get 4 square root of 2 over 7. Okay, does that help? Good. Anything else? Anybody have anything else on any of the homeworks? Or the review that you're already stuck on that you want me to talk about while I'm up here? Or anything? All right.